94. Incline ramp. A 2-pound weight is attached to a 3-pound weight by a rope that passes over an ideal pulley. The smaller weight hangs vertically while the larger weight sits on a frictionless incline ramp with angle theta. The rope exerts a tension force T on both weights along the direction of the rope. Find the angle measure for theta that is needed to keep the larger weight from sliding down the ramp. Now, this question requires trigonometry, geometry, and physics, which is quite a lot. But to dissect this problem, going back to the question, it says that a rope that passes over an ideal pulley. Now, an ideal pulley is just a pulley that's frictionless and has no mass. Now, if the pulley did have friction, then the tensions between these two objects would be different, because the tension on the incline right here must overcome both the gravity, the opposing force, which is gravity, and the friction in the pulley. But it's just simplifying the problem with an ideal pulley. And it sits on a frictionless incline ramp. So this ramp, if this had friction, then this would make the problem more complex. So they're also just simplifying the problem here. Now we're trying to find the angle measure for theta. And with this problem, the tensions, since it's an ideal pulley, the tension is the same throughout the rope. Now the tension is constant. That means tension equals tension. So finding the tension for, let's say, the 2-pound weight here is easy, because the only things that are acting on this object is gravity and tension. And gravity is going down in the negative direction. So you have -2. T is in the positive direction, so it's plus T equals 0. Now I'm equaling it to 0 because since this object is stationary, that means that these forces equal, the sum of these forces is 0. Because if it's 2 pounds going down, tension has to be applying the same force in the opposite direction. Therefore, these two cancel each other out. That's why it's -2 plus T equals 0. And you just would do plus 2 to this side to find tension. So that's 2. Now I'm going to go up here and change the T, since we already solved it, for 2 equals T on this side right here. This one's more complex because gravity, since the object is on a ramp, gravity is being broken up into 2 components. Gravity going parallel to the ramp and gravity that's perpendicular to the ramp. These are essentially components for this vector right here. It is the y and x component for this vector. But the component we're trying to find, because we're trying to find tension, would be the parallel component. So it would be this component right here, not the one that's perpendicular, because tension, right, if the object is stationary, that means tension is going to equal whatever this component is, the parallel. So we're trying to find this component. Now this is all to help us find theta. Now, by the way, what I have in orange are the vectors. So I'm going to show an image right now that shows this right here. As you can tell, that the perpendicular vector is right here, perpendicular to the ramp, and the parallel to the ramp right here. But we're trying to find the parallel vector here, because that one equals, because this one equals this one. If you also want to visualize this vector, it's the same if it was right here. It's forming this triangle right here. But going back, they write out the formula here that we need, that for W parallel, which is the one we're looking for, equals W times sine theta, which that is, W is weight, so mass times gravity, which means that would just be 3g times sine theta. That would equal tension. Now, how do you actually find that? How do they actually find this? But I can write that right now. That tension, in this case, would be 3. And I forgot the g here, that it's going down, right? It's mass times gravity. So because this is weight, so it's 2g equals 3g sine theta. Now this is where the geometry comes in, that as you can tell from here, which the theta here is also right here, which this theta is finding the parallel line here, which is the same thing up here, that it does the opposite over the hypotenuse right here, which is 3 pounds. Now to find that, I have the definition of corresponding angles. That corresponding angles are the angles which are formed in matching corners or corresponding corners with the transversal when two parallel lines are intersected by any other line. So right here, right, it's coming straight down the ramp. This is one parallel line. And right here, since this one is straight down due to gravity, the 3 pounds vector, that's straight down. So these two lines right here are perpendicular to each other. And we can say that the transversal, the line that intersects these parallel lines, is what is intersecting this line and this line. We can say it's this line up here that is intersecting. This line is intersecting these two parallel lines. Now with the transversal, it's formed, which looks really small right now, this triangle. Now it does not fit to scale right now, but this small triangle, this is where this transversal is intersecting these two parallel lines. So I'm talking about this triangle right here. Despite it not being fit to scale at all, this would give you the same angles with this triangle right here. That this forms a 90-degree angle. This is a 90-degree angle here. That as it's going straight down and it's on perpendicular to the ground, that we know this angle, at least right here, is the same as this angle right here. So these angles are the same. This forms, with this perpendicular to the ramp, forms this 90-degree angle. So this angle right here will be the same as theta. Now since this is theta, we know, and we can even use this vector, that right here, that now this is theta. Now once we do opposite right here, opposite over hypotenuse, which that would be 3 pounds, that means we have 3g times sine. This is 3g times sine theta. This is how they got that answer. Now you could just memorize this right here to figure out what theta, how to get tension. So equal to each other, and then you can cancel out the g, left with 3 sine theta times 3. So now you have sine theta equals 2/3, and you just do inverse sine. So if you do inverse sine 2 over 3, you're left with 41.8 degrees, and that is your answer. I hope this was helpful.